Concentrator photovoltaic system is more efficient than traditional solar panels. This method of generating electricity is suitable for areas with high temperatures and solar radiation, DNI greater than 6.5. The module efficiency of this system is roughly twice that of traditional silicon photovoltaics. By positioning the solar panels far above the ground, the technology makes space below them that can be used. The CPV system is predicted to take the place of the present photovoltaic generators. Features: 1. High rate of conversion. The CPV system uses compound semiconductor cells with a high conversion efficiency of 40–50%. The system generates power by moving with the sun and using lenses to concentrate straight sunlight into an intensity hundreds of times higher. The conversion efficiency of one module is roughly twice that of a standard silicon solar module. 2. Compact and thin. The thin and light design of Sumitomo Electric CPV modules lowers the cost of the solar tracker that supports the modules, as well as the freight and on-site installation costs. The entire cost of the power generation system is reduced as a result. 3. Continuous generation of electricity throughout the day. To make the most of the sun's energy from dawn till sunset, the module is mounted on a 2-axis tracker that can adjust the elevation and direction. 4. Effective in warm, sunny weather. The conversion efficiency of semiconductor sun cells does not decline in comparison to silicon solar cells, since it is not much impacted by temperature. The CPV system is therefore very helpful for producing power in areas with high temperatures and sun exposure. While concentrator photovoltaic (CPV) systems and conventional solar cells share the same basic idea, there are some key differences between the two technologies. Systems with CPV are much more efficient. Conventional solar cells have an efficiency of about 20%, and about a fifth of the solar radiation they absorb is transformed into usable electricity. In concentrator photovoltaic systems, a type of solar cell with an efficiency of above 40% is used. Lenses and trackers are needed for CPV systems. Compared to traditional photovoltaic systems, this technology takes a new approach. This method uses lenses to concentrate solar energy on a smaller, more effective solar cell, as opposed to covering a vast surface with solar cells. Because of this, solar tracking equipment is required for concentrator photovoltaic systems in order to maintain the lens's alignment with the sun. The idea is quite similar to that of using a magnifying glass to focus sunlight on paper to burn it. For CPV systems, cooling systems are required. Similar to how a piece of paper can damage solar systems, concentrated sunlight strong heat can. A cooling system must be installed in the solar installation in order to completely remove the heat. Systems with CPV are more expensive. Increasing efficacy always comes at a cost. Currently, the return on investment offered by traditional photovoltaic systems is more alluring. It's vital to keep in mind that CPV solar cells are only slightly more expensive than standard PV cells. Usually, complementary systems increase the price. The short-term cost of CPV solar systems may be reduced by using economies of scale to reduce costs and standardizing the technology. Additionally, it wouldn't hurt if federal and local governments provided special incentives for CPV consumers. Efficiency for conventional CPV systems is typically between 25 and 30%, but it ranges between 16 and 20% for large-scale commercial flat-plate solar panel systems. Efficiency studies conducted in engineering labs revealed even more differences between CPV and flat-panel solar technologies. Under testing conditions, the CPV cells employed by research teams, which convert more than 40% of the light that strikes them into electric currents, produced the best outcomes. The systems of 3 of these groupings even exceeded the 46% threshold. Concentrator photovoltaic technologies, which are now on the market, have demonstrated tremendous potential for more effective solar generation. The most modern systems, according to studies, are capable of managing 100 suns worth of energy. But the market's competition with less expensive flat-panel solar systems has left prototypes in the dust. The Advanced Research Projects Agency, ARPA, of the United States Department of Energy is dedicated to CPV development. On August 24 during the Clean Energy Summit, U.S. President Barack Obama and Energy Secretary Ernest Moniz introduced the Mosaic program, which will invest $24 million in the advancement of CPV solar technology. Why can't current CPV systems compete? The concentrators, which can only convert direct sunlight into energy, do not collect the significant percentage of sunlight that is diffracted by clouds and the atmosphere. Additionally, CPV has been unable to enter mass production due to the high manufacturing costs of concentrator equipment. To aid with it, the Mosaic program enters the picture. The Mosaic umbrella's 11 new CPV programs are investigating a range of system architectures to address performance and cost efficiency challenges. Wave-guiding solar concentrators, single-junction cells that improve concentration in diffuse and indirect light, and the construction of micro-PV cells at a reasonable cost are among the projects on the list. A researcher at the U.S. National Renewable Energy Laboratory in Colorado who is working on CPV technology claims that ARPA is supporting new technologies that will help the industry progress even farther, albeit even where it is now is fairly exciting. For large-scale commercial flat-plate solar panel systems, efficiency ranges between 16 and 20%, and for typical CPV systems, efficiency is between 25 and 30%. The results of engineering lab efficiency tests show an even greater distinction between CPV and flat panel solar technology. The CPV cells used by research teams, which convert more than 40% of the light that reaches them into electric current, produce the best results under testing conditions. 3 of these groupings systems even went over the 46% mark. This shows that these results are remarkably repeatable. The head scientist of the National Center for Photovoltaics measures the effectiveness of solar cells. I wouldn't be surprised if within the next 2 or 3 years, one study group attained 50% efficiency. The reasonable goal of 50% has been established by people. Using various optical elements, including mirrors and lenses, CPV maximizes efficiency by concentrating light into a highly concentrated beam that is directed at a solar cell. To maximize the amount of direct sunlight that the cells receive, the panels are adjusted by machinery throughout the day. It's like moving a magnifying glass while engraving your name into some wood. The use of more efficient, smaller solar cells is made possible by optical components. It is simpler to control the movement of the smaller cells, preventing overheating and degeneration. 1 square millimeter sized cells have even been created in some labs. These cells can produce more electricity in a smaller area than flat panels. The following goal is to create CPV materials that are even more economical and eco-friendly than flat-plate photovoltaics. Engineers are examining recyclable plastic mirrors with reflective coatings made of aluminum. Solar energy has the potential to play a bigger role in the electrical grid as the energy sector gradually replaces outdated fossil fuel plants with photovoltaic and other renewable power plants. There is a rumor that solar is the technology of the future.